Hello friends, welcome to my channel. Here is LeetCode problems. Today's problem number 1043. Partition array for maximum sum, medium level. Given an integer array R, partition the array into contiguous subarrays of length at most k. After partitioning, each subarray has their values changed to become the maximum value of that subarray. Return the largest sum of the given array after partitioning. Test cases are generated so that the answer fits in a 32-bit integer. So we need to partition some array into subarrays at most with size at most k with total maximum sum. How we can do it? I will solve it recursively and what I can do. For instance, we have some problem like some array like this with k equals to 3. So we can divide this array into parts with size 3 at most. So it can be 1, 2, or 3. So each in recursion function we will find sum of each subarray started from the beginning. For instance, we can get one subarray with size 1 and with sum 1 and recursively call the same function on the rest array. For instance, here call f. It's one option. Second option it could be, so we have same array we can use two numbers with maximum value 2 and 2 items, so the total sum 4, and the rest array also we need to call the same function for the rest of array. And third option, we can choose 3 items with maximum value 3 and total sum 9, and the same function f for the rest 2 items. And we need to find recursively some result, so it can be R1, R2, and R3. And we need to choose the maximum value from R1, R2, and R3 and return it. And after recursive calls, we will find the maximum result for the whole array. So let's implement it. First of all, let's define the recursive function helper with one argument start. Start is the started index when we are calculating sum. We need some variable for result. Result is the final sum which we need to return, and also we need helper value max sum equals to 0. Max sum is in our example is the sum of the subarray. So in our example for the first item, max sum equals to 1. For the second two items, max sum is 2. So it's the maximum of the subarray. Uh, in the third line, the max sum is 3. So we need to check all subarrays. So we can do it. I here is the end of subarray. So I is like offset. So it's start up. So it's items after start. So if so we need to update max sum. So max sum is the maximum value of current max sum and current item. Current item is a start plus I. So if they have k equals to 3, we can have 3 subarrays, including only start, start plus start and start plus 1, and start, start plus 1, and start plus 2. So 3 items. And we need to update result. Result is maximum of result. And here we need to do the same things. So we need to multiply max sum. So for instance, here max sum 3, and we have 3 items. So we need to calculate it max sum multiply by number of items. So it's max sum multiplied by number of items equals to I plus 1. And plus recursion call of start plus I plus 1. So the next recursion call will be started from start plus 1, start plus 2, or start plus 3. Depends, or then we how many items we use in calculation, and return result. In our main function method, return function helper with index 0. So we need to find the maximum sum of all items started from 0. Let's check tests. Something wrong. We need to start a mistake. We also need to check if start less than the last item of our array. So we need to check indexes. So tests passed, submitted. Time limit exceeded. It's possible because we have many recursion calls inside each function. To fix it, we need to use local cache like this. It's a function from the package functools, and it will save the result for each start argument, and next time when we meet the same argument, we don't need to call many recursion functions and just return the previously calculated value. So in our case, it will reduce the total time. Yes, now it works and pretty efficient by time and memory. And you can check out the solution in the description below. Thanks for watching. See you tomorrow. Bye.